Welcome. So today we are going over scale copies. So this is from Unit 8. Feel free to take notes. So what are scaled copies? Well, scaled copies are making smaller or bigger versions of something. So I can make a rectangle bigger, or I can make it smaller. I could make a triangle bigger or smaller. And a perfect example of like when you would use scaled copies or kind of the purpose of them is if, say, you're making a map of the United States. You're not going to have enough paper for it to be the exact measurement of how big the United States would be. So you're going to make a scaled copy. You're going to make a smaller version of it. So every like centimeter on the paper might represent like thousands of miles or something like that. And that's what scaled copies are. So with scaled copies, you're going to have something called a scale factor. And scale factors let you know how big or small you're going to make your scaled copy. So if your scale factor is less than 1, then your image will shrink. If it's greater than 1, it's going to stretch. It's going to get bigger. And so that's important to know. So let's say I have a square. Well, my square here has, let's say this is 5, or let's say this is a rectangle. This here is 5, and this is 6. Well, I can double my rectangle. I can make it bigger, a scaled copy. And so let's say my scale factor is 2. I'm going to multiply 5 times 2 and get 10, 6 times 2 and get 12. So this has a scale factor of 2. It went from 5 to 10. It got bigger. Let's say I'm going backwards from big to small. Then it would be 1/2. It's less than 1, right? It got smaller. So that's how you would find your scale factor. All right, so let's practice some scaled copies. And so this is the unit on Khan Academy. As per usual, these are the individual quizzes that you can use to practice, and I recommend doing so before you do the unit test. You can watch the videos if you want, but not required. Okay, so let's explore scaled copy. So I really don't like how they do this. They want you to make a scaled copy of one or the other. This one is getting smaller and this one is getting thinner. So I don't really like how they do these. And so just try your best for these. So it's asking which slider creates a scaled copy? Does shape A create a scaled copy of B, or does B create a scaled copy of A? And that's pretty much what you're doing. And you can make it bigger or smaller. And so they must be the same shape, right? So let's go here. So this, that gets thinner like that. It's not going to happen, right? This one's going to get smaller. And so once again, it has to be about the same shape, right? It's not going to get very thin for one and the other one's still more squarish. And so that's the point of these, right? This here, it's getting bigger, right? This is getting smaller. And you see overall, this stays the same size. This one's a tricky one. So A is a scaled copy for B. But like I said, try your best for those. Those aren't really that important. These are more important. Identify the point in figure 2 that corresponds with K. Well, you can see these are facing the same direction. K is here. K goes with A, right? Or we're to put them on top of each other, and made them the same size. Where would K land? K would land with A. Where would M land? M would land with B. Where would CD go with? CD would go with MN, right? It must goes in that order because C goes with M, D goes with N. Where would BC go with JI? And so that part's very, very easy. You're just matching up the corresponding sides and points. And so now we're identifying scaled copies. So is it a scale copy? Well, this is a 2 by 2 square here, and this one's 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So no, this is not a scaled copy because 2 times what gets us? If that's 7, that should be 7 because these are 2, 2. So when you multiply, so when we multiply by our scale factor, we should get the same, multiply both by the same scale factor. So, 2 times what is going to get us 7? That same number should get us 7 again. It shouldn't get us 9. That's not correct. So that's how you know it's not a scaled copy. So here, 2 times 3 is 6. Is 6 times 3 14? No. Is 4 times 3 12? Yeah, but 6 times 3 is not 14, so that just doesn't work. No, it must work for every side. All right, here, this is 2, that's 4. 2 times 2 is 4, so that's good. This is 1, 2, 3, 4, 5, 6, 7, 8, and this is 1, 2, 3, 4. So 4 times 2 is 8, so that's good. 1, 2, 3, 4, 5, 6, that's 6, and that's 3. 3 times 2 is 6. No need to do the diagonal side. This is good. That's a scaled copy. And so I have to be able to multiply all the sides on the first figure by the same number, which is the scale factor, to get to the next. And so that's a very important note to make, right? And so that should be something we want to put down on here. You should be able to multiply all the sides of a figure by the scale factor to get to the corresponding sides of the second figure. So this is important. Feel free to write that down. All right. Even. Oops, I tried to put a box around it. I'm not used to this whiteboard. That's not correct. I'm just having, there we go. Put a box around it. That's important. All right, moving along. Okay, so that's identifying scaled copies. All right, so now we're identifying scale factors and drawing. So now we're finding the scale factor. Remember, the scale factor is what do I multiply the first one to get to the second? So what is the scale factor from A to B? So how do I get from 3 times what? Wait, is that 3? 1, 2, 3, 4. Sorry. 4 times what? Right, because that's figure A. So 4 times what? We can make a one-step equation. You learn those in 6th grade. Equals 2. Well, solve for x. Divide both sides by 4. Always simplify your fractions. 4 times 1/2 gets me 2. So what's the scale factor? 1/2. All right, so what about this one? How do I get from 7 to 28 or 16 to 56 or 14 to 56 or 16 to 64? Well, I multiply all those by 4. I multiply figure A, all corresponding sides, by 4 to get to figure B. And so this is also very simple. How do I get from 1 to 3? I multiply by 3, right? If that's 1 and that's 3, 1 times 3 gets me A to B. Careful when you're going from A to B or B to A. When you're going from big to small, you know you're going to get a number less than 1. For example, 4 times 1/4 for this one, sorry, is 1. Okay, my nose is a little stuffy. Moving on, identifying the scale factor. What could be the length of the scaled copy of this rhombus? So the scale factor is greater than 1. And so you can see the side length here is about 1, 2, 3, 4, 5. So if it's greater than 1, it needs to be bigger. And so you pick the ones that are bigger. If I'm going down like this one, less than 1, it needs to be less than 8. So pick all of the ones that are less than 8. Very simple. All right, now we're looking for missing sides, which is important to do. What is the value of x? Figure A maps to figure B with the scale factor of 4/9. So figure A, so x times 4/9 gets us 16, right? One-step equation, solve for x. How do I do that? I divide both sides by 4/9. And if you don't know how to do one-step equations, please review them from 6th grade math. You could do so on Khan Academy. So this becomes 16 divided by 4/9, which is 16 times 9/4. You can use a calculator. 16 times 9 is 144 over 4. And so 144 divided by 4 gets us 36. So x is 36. 36 times 4/9 gets us 16. We found the missing side by using our scale factor. And so same thing here. What is the value of x? Well, we can go from this to this way. 27 times what gets us 45? If we don't know, divide both sides by 27. 45 divided by 27 is 5/3. So our scale factor is 5/3. So 18 times 5/3 is 30. So x is 30. If you do not know how to deal with fractions, you need to review that from 5th grade math, which you could do so on Khan Academy. Lots of fractions here. Figure A maps to B. Okay, so A, its scale factor is 1.5. So 2 times 1.5 gets us the missing side, which is 3. That's easy. All right, so how do I get from 35 to 45? Well, we find the scale factor. 35 times what equals 45? Well, divide both sides by 35. Simplify that, and you get 9/7. And so this times 9/7 is 45. Or you can go backwards if you're going this way. 27 divided by 9/7 gets us x. So you can go back and forth. And 27 divided by 9/7 is 21. And so I want you to practice that part of the unit first before we get to the next part of this unit. And so once again, things we should know. Things we should know for this unit. Fractions, decimals. That's from 5th grade math. And you also go over them in 6th grade and even maybe before then. So, technically this is elementary. Elementary. I'm just going to abbreviate to 6th grade math. And then we should also know how to do one-step equations, how to set them up, how to solve them. And so if you do not remember this stuff, review it. You can type that in Khan Academy and find it. Or if you need help, just feel free to reach out. All right, so good luck on the first part of this unit. Let me know if you have any questions. Practice, practice, practice until the next video when we finish this unit. Good luck.